Hello everyone, this is SP Gubbi online classes for Ncert 10th standard and Cbse 10th standard for mathematics and science. So today we are going with the most important concept in similar triangles, that is Thales Theorem or basic proportionality theorem. So prior to this, in the previous session on similar triangles, we had discussed the similarity of polygons. So if any two polygons with equal number of sides has to be similar, then their corresponding angles should be equal and their corresponding sides should be proportional, that is in the same ratio. For any two polygons of same number of sides to be similar, both the conditions are compulsory required. On the same line, triangle is also a polygon. It's the basic polygon. I had told you the definition of polygon in the previous session also. So in case of triangles, when we come, in order to prove that any two triangles to be similar, no need to prove that their corresponding angles are equal as well as their corresponding sides are proportional. Out of these two conditions, any one condition is enough. This was the criteria we discussed. So here the main thing is, in case of triangles, when we speak about triangles, if two triangles are equiangular, that means their corresponding angles are equal, automatically their corresponding sides will be proportional. Or reverse to that, in any two triangles, if corresponding sides are proportional, they will be equiangular. So if they are equiangular, then their corresponding sides will be proportional. If their corresponding sides are proportional, then they will be equiangular. So in order to prove that two triangles to be similar, any two triangles, you can take two acute angle triangles, you can take two obtuse angle triangles, you can take two right angle triangles, any type of triangles you can take. To prove that two triangles are similar, it's enough to prove that their corresponding angles are equal or their corresponding sides are proportional. So out of these two conditions, any one condition is enough. So this criteria applies only for two triangles, not for any other polygons. For any other polygons other than triangle, if you want to prove that they are similar, you have to prove that their corresponding angles are equal, as well as you have to prove that their corresponding sides are proportional. This is the condition. So now, based on equiangular triangles, a very great famous mathematician, Thales, he gave out a very important statement, that is a truth regarding equilateral triangles, that is equiangular triangles. In case of any two equiangular triangles, the ratio between their corresponding sides will always be same. In the sense, the ratio of corresponding sides of two equiangular triangles is always same. This was the truth given by Thales. So for giving this truth, he used the basic proportionality theorem, where nowadays it is called as the Thales Theorem, or in short form we call it as BPT, basic proportionality theorem. So in this theorem, we are going to logically prove that if you want to prove, that is, if if you want to prove any two triangles to be similar, both the conditions are not required. Any one condition out of this is required. To prove this, we need a previous knowledge. This previous knowledge is called the basic proportionality theorem. Until now, we went with some numericals. I had drawn some geometrical figures. I showed you how it comes. I took my own values. I put it for the sides of the equilateral equiangular triangles. I took the ratio and I showed you how the ratios are going to come equal. That is mathematical thing. But logically, I will repeat once again. Logically, if you want to prove that if two triangles are similar, both the conditions are not required to prove that both the triangles are similar. Just one condition is enough. In order to prove that both the conditions are not required, any one condition is enough. To prove that logically, that statement logically, we need the knowledge of Thales theorem or basic proportionality theorem. So that was given by Thales. I will repeat it once again. Please follow this. In order to prove two triangles to be similar, both the conditions are not required. Any one condition is required. In order to prove this, we need the knowledge of Thales theorem or basic proportionality theorem. So this Thales theorem or basic proportionality theorem was given by Thales, a great mathematician. So here, before learning this basic proportionality theorem or Thales theorem, we need some previous knowledge which you have learned in your 8th and 9th standard classes. So if you have not learned it, it's okay, no problem. I will teach that now. I will convince you that, then we will go with the theorem so that you can understand better and you can enjoy the theorem. So here, before proving any theorem, the previous knowledge which is required from your previous classes, previous geometry what you have learned in your previous classes, they are called lemmas. So here, in order to prove any theorem, we may need one lemma or two lemmas or three lemmas or four lemmas. It depends upon the theorem. So here, in order to learn basic proportionality theorem very successfully, you need to recall two important that is basic concepts related to your previous class geometry. That is two lemmas. Lemma 1. We'll go with that. Please follow. Let us go with lemma 1. So here, lemma 1 is when you have an equilateral triangle or an acute angle triangle. It's an acute angle triangle or an equilateral triangle. Okay, I will take this as an acute angle. In this acute angle triangle, BC is the base. BC becomes the base, and if you draw a perpendicular from the vertex to the opposite side, that becomes perpendicularly. That becomes the height. So that is AH is the height. I will call it as by H. AH becomes the height. So here, in an acute angled triangle, please remember this. In an acute angled triangle, the height of the triangle remains inside the triangle. The height of the triangle remains, or it will be inside the triangle. So, when you take a right angled triangle, if you take it as triangle PQR, this is right angle. The side PQ itself is the height of this triangle. PQ itself is the height of this triangle. When you take an obtuse angled triangle, this is an obtuse angled triangle. Take it as DEF. This is angle E, which is obtuse angled. So it's measured the angle. This measure more than, that is 90 degrees. Therefore, it's an obtuse angled triangle. So in case of an obtuse angled triangle, the height, that is the line drawn from the vertex to the base, which is perpendicular to the base, it lies outside the triangle. So here in an equilateral triangle or an acute angle triangle, the height of the triangle lies inside the triangle. In case of the right angle triangle, the side of the triangle itself is the height of the triangle. In case of an obtuse angle triangle, the height of the triangle lies outside the triangle. So here you have to extend this side so that you can make this perpendicular to meet the base. This is lemma 1. So I will repeat. In an equilateral triangle or an acute angle triangle, the height will be inside the triangle. In a right angle triangle, the height will be one of the side of the triangle. In an obtuse angle triangle, the height of the triangle lies outside the triangle. So here you can take it dp. dp is the height which lies entirely outside the triangle. So if you want another figure like this, you can go. So this is again an obtuse angle triangle. This is obtused. So it is take it as ABC. This becomes the height, and you have to extend this base, and you will get 90 degrees. So if you take it as AM will be the height of the obtuse angle triangle. Right. So this is lemma 1. You should be, if you know this, you can easily learn the theorem. Okay. So we'll go with lemma 2. Lemma 2. Consider two parallel lines. Let us call it as M. Let us call this line as M. So there are two parallel lines. So the two lines which do not meet each other even if they are extended indefinitely, they are called as parallel lines. Or two lines are drawn in such a way that if they do not have any point in common, then they are called as parallel lines. So these are the two parallel lines. So here I have a triangle in between the two parallel lines where the vertex of the triangle lies on one of the line. I will take it as ABC, and I will draw another triangle. This is the triangle here. I will call it as PBC. So ABC and triangle PBC are on the same base BC. Basically, that is, triangle ABC base is BC. Triangle BPC base is BC. So both the triangles lie on the same base and they are in between the same parallels. That means if you draw a perpendicular here and if you draw a perpendicular to here, so this itself becomes the perpendicular here. So the height of both the triangles are same because they lie between the same parallels. So if two triangles are on the same base and between the same parallels, then they are equal in their areas. That is, area of triangle ABC will be equal to area of triangle BPC. So this is lemma 2. So this is what you have learnt in your 9th standard triangles chapter in geometry, right? So once again, in an acute angle triangle, the height remains inside the triangle. In a right angle triangle, one of the side is the height of the triangle. In an obtuse angle triangle, the height comes outside the triangle. If two triangles are lying on the same base, and if they are in between the same parallels, then the area of triangle, that is, we can write it like this: area of triangle ABC is equal to area of triangle BPC. This is the thing. So condition is both the triangles should have the same base and they should lie between the same parallels. Right. So if you are aware of these two concepts, basic proportionality theorem or Thales theorem, it's a cakewalk. It will be very easy for you. Right. Okay. So before proving an enunciation logically, we need to understand the algorithm what we follow there. That is the step-by-step process what we follow before proving a theorem, which is very much required. So here, let me write the statement first. This is the statement or enunciation. Right. If a line is drawn, parallel to a side of a triangle, the line is drawn parallel to a side of a triangle, then it divides the other two sides proportionately. So this is the statement or the enunciation. Now, before proving any theorem, most important thing is first you have to read the statement. The entire statement of the theorem has two parts in it. First part is the part of the statement starting from if to then is called the hypothesis. That's the hypothesis part of the statement. And the second part of the statement is from then to the other part, that is the end of the statement, that becomes the conclusion. So in the statement there are two parts, one is the enunciation, another is conclusion. So here, let me identify the enunciation, that is hypothesis. If a line is drawn parallel to a side of a triangle, so this is the hypothesis part of the statement. So in this hypothesis part of the statement goes like this. In a triangle, so you have to imagine the words, the geometrical figures involved in the statement. That is geometrical figure. In a triangle. So in your imagination, you should get a triangle. In a triangle, if a line is drawn parallel to a side of a triangle. So triangle is the geometrical figure we have got in your mind. So you have a triangle, you have to imagine a triangle. In that triangle, you have to draw a line parallel to any one of the side of the triangle. So you have this side, you have this side, and you have the base. So you can draw that line parallel to either this or this or this. So that's the imagination, right? So hypothesis part of the statement tells us to imagine the geometrical figure and what is to be done with that geometrical figure. And for theorems, they won't give you any geometrical figures. You have to draw your own figure from your imagination. So imagine first, if a line is drawn parallel to a side of a triangle. So imagine a triangle, there are three sides in a triangle. Out of any three sides, take one side, select one side, it is your wish. Select one side, you can take any triangle. You can take acute angle triangle, obtuse angle triangle, right angle triangle. You can take any triangle you want. No restrictions. So, in any triangle, if you draw a line parallel to a side of a triangle, then the line drawn to the parallel, that is one of the side, it divides the other two sides proportionately in the sense in the same ratio. It divides the other two sides in the same ratio. Okay. Now, I will tell you the algorithm what is to be followed, the steps what is to be followed. If a line is drawn parallel to a side of a triangle, that is hypothesis. Hypothesis part of the statement, using the hypothesis part of the statement, you have to draw the diagram by yourself. You have to draw your own diagram. You have to name the diagram by yourself. So don't stick with the names given in your textbook. Be creative, give your own names. Right. So diagram, So here, when you draw the diagram, you are going to name the vertices. So this is triangle ABC, this is the line, so everything you are going to name it. So describe the diagram, that is the description of the diagram is written in data. That is the data of the theorem. Now, using the hypothesis part of the statement, you are going to draw the diagram and you are going to write the description of the diagram in the form of data. Next comes, what is to be proved? To prove that. What is to be proved? So, in order to write what is to be proved in the theorem, you have to read the second part of the statement. The second part of the statement starts from then it divides, it in the sense the line, it divides the other two sides of the triangle proportionately. So you have to write that line drawn parallel to one side of the triangle, that line divides the other two sides in the same ratio. So that is to be written here. So what is to be proved will be in the conclusion part of the statement. So what is to be imagined, what is given to you will be in the hypothesis part of the statement. What is to be proved will be in the conclusion part of the statement. So you have to write the conclusion part of the statement in the form of to prove that. Then we will go with the necessary part, that is construction, if required. If required. At what point do we get the construction here? If the given data is not enough, if the given data is not sufficient to prove what is to be proved in the theorem, then we go with an extra geometrical alterations in the figure, that is construction. So if it is required, we can do this. If data is sufficient to prove this, then no need of construction part. So after this, we go with the proof. So this is the heart of the theorem. Proof. You have to practice this. So how to write the proof? So here, proof is to be written by using your previous knowledge. That is axioms. You can use postulates. You can use theorems. That is results of previous theorems, that what you have learned in your 8th and 9th standard classes. You can use the results of previous theorems. You can use that is other enunciations. So enunciation, all the enunciations are not being proved in your previous classes. Some of the enunciations which are not proved, they can also be used in the proof wherever required. Wherever required, right? So if you are very good in your previous year's geometry, you will be very good in your 10th standard geometry, right? So this is logically we are going to prove this. So once again, the statement is here. The statement has two parts. One is the first part is the hypothesis, second part is conclusion. By reading the hypothesis part of the statement, you are going to imagine the diagram, you are going to write your own diagram, give a name of your own, then we will go with the data. You are going to write the diagram and write the data. Description of the diagram is data. Now, we will read the second part of the statement, that is conclusion. Then we will write what is to be proved. So in conclusion itself, it is given what is to be proved. Then if required, if the data is sufficient, then construction is not required. If data is not sufficient to prove this, then we will go with the required step, that is construction. Next we will go with the proof. So in this proof, you will be having, you may use, right, axioms, not all axioms, required axioms, postulates, results of previous theorems, and the enunciations which are not proved as theorems, right. So these are all the things required for the proof of a theorem, logical proof for a theorem, right. So this is the steps required. This is the algorithm, right. Please remember this. So we'll go with the proof of the theorem, which is very important. So this theorem will be asked in your examination for 4 marks. It's very important and it's deadly easy. It's very easy because you know the lemmas. Okay. So if a line is drawn parallel to a side of a triangle, so in my mind I am getting a triangle. So to one of the side of the triangle, I have to draw a line parallel to the side of the triangle. So I will select the base. So first I will write the diagram. So I will go with the steps. This is the first step is diagram. So I draw a diagram now. Diagram of a triangle. So this is okay. This is triangle. Okay. I will take it as triangle ABC. This is the triangle here. I can take any triangle as I told you. You can take any triangle you want. Okay. So this is triangle ABC. If a line is drawn parallel to a side of a triangle, so I have to select a distinct point on AB and a distinct point on AC such that when I join those 2 points, that line should be parallel to the base. So I am going to select 2 points on 2 sides. So I will select, okay, I will take this point as D and take this point as E. So DE are the 2 distinct points on the 2 sides of the triangle. I am going to join these 2 points. So now this line DE is drawn parallel to the side of the triangle. So I have selected the side BC. So I have drawn a line parallel to the side of the triangle. So if a line is drawn parallel to a side of a triangle, I have done it. A line is drawn parallel to a side of a triangle. So in this triangle, this is one of the sides. For this side, I have drawn a line parallel by selecting 2 distinct points on the other 2 sides of the triangle. Now, so here this is the diagram. So I have to write the data now. So the description of the diagram is the data. So I will write the data. So here I will go with the data here. So in triangle, okay, in triangle ABC, DE parallel to BC, D and E are distinct points on AB and AC respectively. So this is the description of the diagram. So this is the diagram and this is the description of the diagram. So by reading the hypothesis part of the statement, I have drawn the triangle. I have drawn this line parallel to this one of the side, and the description of this entire diagram I have written as in the form of data. Okay. So I will go with the conclusion part now. Then it divides. It means who? That is line. Then it divides the other 2 sides proportionately. Proportionately in the sense the line is going to divide the other 2 sides of the triangle in the same ratio. That is in the same ratio. So this point D, in what ratio the point D divides AB, in the same ratio the point E on AC divides AC. So you have to prove that. You have to prove that. Okay. The ratio, that is the point D divides AB in the ratio AD is to BD, and point E on AC divides it in the ratio AE is to EC. So here we have to prove that AD by BD, that is AD is to BD is equal to AE is to EC. So you have to prove that. So here AD by BD, that is AD is to BD, can be written as AD by BD, and AE is to EC can be written as AE by EC. So you have to prove that AD by, that is BD, is equal to AE by EC. AE by EC. So this is the thing what we have to prove. So the line, when you draw a line parallel to, this is compulsory. If you do not draw the line parallel to this side of the triangle, then it won't divide these 2 sides in the same ratio. Maybe the ratio may completely change. So if this line is drawn parallel to a side of the triangle, then this line divides the other 2 sides of the triangle in the same ratio. So that is mathematically AD by BD is equal to AE by EC. Now In order to prove that AD by BD is equal to AE by EC, by using this data, it's not practically possible. So therefore, I will go with a little bit construction. I will enhance the data very logically without altering the data, the given data, right? So now, join BE. You have to join this BE and join this BE. Join this CD, join BE and CE. So join BE and CE. Join BE and CE. Okay. Now draw ED, that is okay, EF, EM or EN. Okay. Now draw DM, DM perpendicular to AE. Draw DM perpendicular to AE and EN perpendicular to AD. So this is the construction once again. Draw DM perpendicular to AE. Draw DM perpendicular to AE and EN perpendicular to AD. EN perpendicular to AD. Right. So this is the construction, right? So very important. Once again, join BE, join CD, draw DM perpendicular to AE and EN perpendicular to AD. So this is the required construction. So if this construction is done, this adds up to the excess of data so that we can prove this very easily, right? So we'll go with the most important part of the theorem, that is the proof. Okay, so we'll select two triangles. Be very careful in selecting the two triangles here. So take triangle ADE. In triangle ADE, I hope you can see this. The triangle which is on this line, in triangle ADE and triangle DBE, this triangle. In triangle ADE and triangle BDE. Okay, so in triangle ADE and triangle BDE. So in both the triangles, right, we will take the area of this. Area of triangle ADE is equal to, that is ADE is equal to half into, we will take this as the base, that is AD as the base, half into base it is AD and EN is the height, because ADE triangle is an acute angle triangle. So therefore, the height of the acute triangle lies inside the triangle itself, as I told you in lemma 1, right? So AD is the base, so and EN is the height. So AD into EN. So area of triangle ADE is equal to AD into EN, right? So now let us take area of triangle BDE, this triangle just below this, area of triangle BDE. So area of triangle BDE is equal to half into, let us take BD as the base. So here we can see this angle here in this triangle BDE, this angle is an obtuse angle triangle. So therefore, the height of this triangle lies outside the triangle. So this is the height of triangle BDE, so that the base is extended until here. So here, according to lemma 1, triangle BDE is an obtuse angle triangle. Therefore, its height lies outside the triangle. So area of triangle BDE is equal to half into, BD is the base, and EN or NE is the height. EN is the height. So now let us take the ratio between the area of triangle ADE and area of triangle BDE. Let us take the ratio. So therefore, area of triangle ADE by area of triangle BDE is equal to half into, area of triangle ADE is equal to half into AD into EN. AD into EN divided by half into BD into EN. So here half and half constants cancel, En and En cancels, so you are left over with AD by BD. Take it as equation 1. Let us take it as equation 1. Right now, we will go with the next triangle, next two set of triangles. Again select triangle ADE in this case. In triangle ADE and triangle C, okay, and in triangle ADE and triangle CED or DEC, this triangle, this side, below this side. So in triangle ADE and triangle DEC. So let us take it. So in triangle ADE and triangle EDC. EDC, right. So now we will take the area of triangle ADE. Now in this case, for the second time we are taking area of triangle ADE. Now we will change the base. So in triangle ADE, let us take AE as the base, so that DM becomes the height. Very simple. In the last this one, here in this case we have taken AD as the base and EN as the height. So in this case, second time we will take AE as the base and DM as the height. So area of triangle ADE is equal to half into base is AE into height is DM. Right. So now next we will take area of triangle this one below this, that is EDC, area of triangle EDC. So area of triangle EDC is equal to half into, now if you consider triangle EDC here, EC becomes the base. EC becomes the base. Here, this is the base. Right? So as this is an obtuse angle triangle, so this is the triangle here, this is obtuse angle. So therefore, if this base is extended, then this becomes the height. Once again, in triangle EDC here, EC is the base. When you extend the base and draw a line perpendicular to the base which is extended from the vertex, so here DM becomes the height of this triangle, because triangle DEC is an obtuse angle triangle, right? So in triangle DEC, half into EC into DM. So EC into DM, right? So we will take the ratio between the areas. So area of triangle ADE by area of triangle EDC is equal to half into AE into DM by half into EC into DM. So half and half cancels, DM and DM cancels. Here left over is AE by EC. Take it as equation 2. Right. So very important results. Both the results are very important. So now here triangle DBE, this is this triangle, that is triangle BDE, this triangle, and triangle DEC, this triangle, are having the same base DE or on the same base DE and between the same parallels, because you can see the vertex lying here, you can see this triangle's vertex lying here. So therefore both the triangles, that is this triangle and this triangle, they are lying on the same base DE and between the same parallels. So according to our lemma 2 triangles lying on the same base and between the same parallels, then they are equal in areas. So we write that triangle BDE or DE, we have taken BDE itself, triangle BDE and triangle EDC are on same base, we have to mention the base here, that is same base DE and between the same parallels. So two triangles, this triangle and this triangle, they are lying on the same base and between the same parallels. Then according to lemma 2, their area should be equal. So therefore area of triangle BDE is equal to area of triangle EDC. So both the areas of triangles are equal. So now take this as equation 3. Take this as equation 3. Now let us compare equation 1 and 2. Let us see this. Area of triangle ADE by area of triangle EDE. So here it is area of triangle ADE by area of triangle EDC. Now in both the equations here and here, numerators are equal, but denominators are different. So here area of triangle BDE is there, here we have area of triangle EDC. But in equation 3 we have proved that area of triangle BDE, that is equal to area of triangle EDC. Just now we have proved that. So in both the equations, numerators are equal, denominators are also equal from equation 3. So therefore from 1, 2 and 3, this entire thing they are equal. So these two things which are equal to these two things. That is AD by BD is equal to AE by EC. So if two things that is AD by BD is equal to AE by EC, these are the two things equal to the same thing, that is this and this. According to the axiom, if two things are equal to the same thing, then they should be equal to one another. So this is very important. Okay. So from 1, 2 and 3, AD by BD is equal to AE by EC. So this is what we had to prove. So hence it is proved. So this is the most famous Thales theorem or basic proportionality theorem, which is very important for 4 marks. So you have to practice this. If you have any doubts, please send it to me through WhatsApp. Please watch the video again and again so that you get a good grip on this subject. Right? So this is for 4 marks. So I hope you enjoyed the entire session. So in tomorrow's session, we will be going with the converse of basic proportionality theorem and related 1 mark questions. Right? All the best.